Good day, 20-1s, and welcome to the Chapter 8, Chapter 9 combined chapter, Systems of Equations and Inequalities. These two chapters finish off the course. The big thing is these are two really small chapters. The Systems of Equations doesn't have really a lot of new material, so it's quick. It's one lesson really, or two lessons, I guess. And then the inequalities, not a ton in there, so we combine them into one chapter. So that's what we're looking at for the next few lessons. It is Chapter 8. We'll get done in 2 lessons, and then Chapter 9, about 3 lessons to bring everything to a close. So here we go. Let's talk systems of equations. Before we get into what to do mathematically, a little bit of background, because systems of equations is not new to us. This is a process, and all the work that we're going to do was covered in the 10C program. So what a systems of equations is when I need to algebraically solve for 2 unknowns, because last year we would have had something like 2x plus 6, and then maybe y equals 4x minus 7. And we want to know what are the x and y values. So that's what a system is. And if you have to call it a system, you have to have 2 equations, because you can't solve for 2 unknowns if you only had 1 equation. So a system is saying you have multiple equations and multiple things to solve for. Now, that was last year where you would have a linear and a linear. No squared values in there, so we know it would be a line and a line. So this is referred to as a linear system. And a linear system, as a quick review, there's 3 situations that can occur. In general, if I have my Cartesian grid, because if you recall, and the first thing we're going to do is we're going to solve these graphically, is if I had 2 equations and I created the lines, because that's what y equals 2x plus 6 really is, and I'm just jotting stuff down. I'm not doing y equals 2x plus 6, so please don't hold me accountable and say that's not correct. But it would maybe be something like that. And then we would have the second equation, which is 4x minus 7. Well, in that case, you might have something that looks like that. So there's the 2 lines. And what we learned last year is that where those 2 lines intersect, that's the one xy point that works and is on both lines, both equations. So that point of intersection would be xy. So that's a linear. Now, the other thing we talked about last year is unique situations. I could have 2 lines from my equations, and those 2 lines could end up being parallel lines. And if I have parallel lines, there is no point of intersection. So it's possible that where the first case we could have 1 solution, it's possible we could end up with 0 solutions. There might not be a solution to an equation or a system of equations. The last situation that we looked at last year or last course was the fact that maybe you have some form of a equation that gives you a line, and then you end up with a second equation and line that's directly on top. Well, if I have 2 coinciding lines, that's going to be an infinite number of solutions. Every single point on those 2 lines are a solution because they both work. So there would be infinite solutions. So that's what a system is, and that's what we did last year. This year, honestly, it's not going to change a lot, except instead of just having linear, we're going to now be solving linear quadratic systems. And a linear quadratic system, well, is exactly what it says. You're going to have 2 equations, and one of those equations will give you a line of some kind. There's your linear. And then the second equation would give you a quadratic. Somewhere, somehow, you're going to end up with a parabola. So in that case, if we have 2 equations, one being linear, one being quadratic, we're still going to have points. Here's an xy point, the first xy point, x1, y1, but we also have a second point of intersection, which would be the x2, y2 point. So it's possible in a linear quadratic that we're going to solve and get two solutions for a linear quadratic. The other possibility with a linear quadratic, in a linear quadratic system, it is possible that we could end up with quadratic, and then we would have a linear maybe down there. If that's the quadratic and linear equations that were given to us, when we went to solve it, we would discover that there are no solutions again. It's possible to have a linear quadratic system without solutions. And then the last possibility would be, given a linear and a quadratic, maybe we have the quadratic, whatever it looks like, could be absolutely anywhere, but our linear maybe just, that should only be 1 point is what I was looking for. My sketch isn't perfect, but we would only have 1 point. So in that case, it's possible there's only one solution. So linear is what we talked about last course. Now looking at a system of equations that might be a linear quadratic, which could give two solutions, it could give zero solutions, or it could give one solution. And the last situation we will be solving for is a quadratic. So that's the other system that we are going to work with in this course. Quadratic, well, obviously that's going to be a parabola and a parabola. And when you have a parabola and a parabola, again, we have to consider what are all the different possible solutions we could have. Well, I could have the exact same parabola possibly on three different systems, but, well, the most common would maybe be the fact that we could have a second quadratic that gives 2 points of intersection. So what we could end up with are two solutions. We could end up with a second situation where maybe the second quadratic and the first quadratic don't intersect at all. So it's possible to have a system of quadratics where there are no solutions. And then the last one, well, it's possible that we have a second quadratic that just will barely contact, and that will give us 1 point of solution. So quadratic, we're going to have the possibility of two solutions, we're going to have possibility of no solutions, and we're going to have the possibility of one solution. So not a lot different in terms of what we're trying to accomplish from the past. It's just that we're using different equations than strictly a linear with a linear. Now, the last little bit before we get started, and this is what we're going to talk about today, is solving systems. And just as a quick overview as to where we're headed, and this is going to be the rest of this video, it's a little bit longer because we're doing everything at once, but it's all review. Solving systems, we can do it graphically. On your calculator, how do you graph the two lines, and then you want to find where are the points of intersection. So that's one way to solve. The second way to solve, and the third way to solve, these are algebraically. Please remember, as we've talked about throughout this course, algebraically means you must show your steps. If you don't show work, you just put an answer. The assumption is it was done graphically. Algebraically requires work. But the second process is substitution process. And the third process is the elimination process. These two processes both work algebraically. Which one's better than the other? Some questions will lend itself to one. We're going to look at both ways to solve. For the most part, you will be given a question and told to solve algebraically. Which process you use will be totally up to you. So, with all of that being said, here we go. Let's jump into solving. Now, solving systems graphically on our calculator, well, if we take a look page 3, there's our first example. Y equals 3x minus 4 and y equals x squared minus 4. We can see, hopefully, we understand that this is a linear quadratic system. So that's what we want to work with. Now, in order to do this with our calculator, what's important is we need to, first of all, input each equation into the calculator using the y equals button. Please know that the first one should be put in as y1, and the second equation should be put in separately for y2. And then we want to graph. Please make sure that when you do go to graph, that you need to see the entire graph, so you might have to change your window settings. So, here we go. On our calculator, we need to plug in those two equations in the y equals. So I'm going to pull up y equals, and I need to make sure that I am doing the correct question. Let me just go back. I don't want to do the wrong question because that will mess people up potentially. So we want to go to our y equals, our first graph, or first equation that will create the first graph is y equals 3x minus 4. I want to scroll down to y2, and I want to graph x squared minus 4. There's my two equations that can be turned into graphs. I graph it. I could change my window settings possibly if I wanted to make it a little smaller, but I see the 2 points of intersections of the two graphs, so I need to put down both solutions, not just one of them, to get solutions. Like it says, we want to go second trace. We want number 5, the point of intersection, because the point of intersection is our solution. So for that first point of intersection, the calculator asks, first curve, the first graph, yes, please. Second graph, yes, we want to include that. Guess the answer, yes, please do. And the point of intersection is 0, -4. So 0, -4 is one of the solutions. We need to do the second solution, so we have to start over. We go second trace a second time. We want number 5, the intersection. Well, use your cursor or move your cursor so that you're close to the point of intersection for accuracy. Yes, we want the first graph. Yes, we want the second graph. Yes, please guess. And the second solution is 3, 5. So for this, we ended up with the solutions being 0, -4. And the second solution we found was 3, 5, graphically. Not a big deal, not too much difficulty. Verify though, you can always verify. Some questions might ask you to. I will do one just to review. To verify is we want to take our solution and make sure that it does work in the system. But we have two equations, so I need to verify 0, -4 in both equations. So we have y equals 3x minus 4, and we think our solution is 0, -4. So my y value is -4. 3 times 0 minus 4. -4 on the left side. 3 times 0 is 0, minus 4 is a -4. Left side equals right side. That's a good thing. 0, -4 is a solution. I also need to verify my y equals x squared minus 4. So using 0, -4, because our solution has to work in both equations. So you need to verify both. We think y is -4. X we believe is 0. Squared minus 4. So I solve the right side. 0 squared is 0 minus 4. -4 comes down. Left side equals right side. That's a good thing. So 0, -4 is definitely a solution. I can do the same verification I should for my 3, 5. So for the y equals 3x minus 4, y is 5, 3 times 3 minus 4, 9 minus 4 gives us 5. Left side is 5. Left side equals right side. So the 3, 5 works for the first equation. Does it work for the second equation? Y is 5. X squared would be 3 squared minus 4. So we have 9 minus 4. We get 5 on the right side. There's a 5 on the left side. So left side equals right side. Our solution, well, it worked on the calculator. It's possible we made an error punching it in, but we verified both solutions in both equations, so we know that's correct. There's solving a system graphically. Page 4, maybe pause the video. Example 6, give that one a try. See what you come up with. Now the first thing, hopefully I didn't talk about it, remember we have to put into the calculator the y equals. So we need to make sure the y is isolated in our equations. Here we have a positive y, so we're going to leave it. But the 16x and the 2x squared need to change sides, which means we're going to end up with the equation y equal to negative 2x squared minus 16x minus 26. That's the equation that we should be plugging into our calculator. Now the second equation, we have a negative y. I don't want a negative y, so I'm going to move that to the other side to give me a positive y, which means my negative 19 now goes to go to the other side so that the y is isolated but positive, and you will have an x squared plus 8x plus 19. There's the values or the equations that we need to substitute in to get our solutions. So pull up the calculator. I want my y equals. I'll clear what I had. And our equations, negative 2x squared plus 16x plus y. Whoa, I apologize. Let me start that over, reading the wrong thing. Y is negative 2x squared minus 16x minus 26. There's my first equation. Second equation was x squared plus 8x plus 19. There's my second equation, and now I want a graph. There I can see my two parabolas nicely. I could make it a little smaller, my window settings, but honestly, it's going to work for me. So 2 points of intersection I see. Second trace, intersect points is what we want. So put my cursor close to the first point of intersection, first curve, second curve, guess the answer, and we get negative 3, 4 as one solution. Now I find the second one, second trace. I want the point of intersection, and I need to move my cursor close to the point of intersection that I want to work with now. Enter, 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 and negative 5, 4. So we can go back now and say that our solutions for this system, the solutions being negative 5, 4 and negative 3, 4. Now, just for the length of the video, if you wanted to do verification to practice, you could. Always make sure, even though we manipulated, you always want to verify in originals. You would plug the negative 5, 4 into original. You would plug the negative 3, 4 into the originals. Give you a little hint, everything verifies correctly. You can give that a try. So that's graphically solving. Graphically solving, like I said, usually you're going to have to do it algebraically, but knowing how to do it graphically is a great way to check your work. And if your algebraic and your graphic don't match up, well, you need to check your algebraic. So here we go. This is going to be a little bit longer video. We're already 20 minutes in, but It's all the same type of work, and it's not new. So we're going to plug through. Substitution, first algebraic process. Here we go. Substitution, the first thing we want to do is we want to isolate a variable in one of the equations. It doesn't matter technically which variable you isolate. However, you will always have one variable that isolates nicely. We could isolate this x, this y term, that x, or that y. All of those four variables could be isolated. However, I really hope you're looking at this x here saying, that x is already by itself. I could isolate it fairly easily, and so that's the one we should isolate, because that's, in my opinion, we want to get that x by itself before y has to move over. So x equals 6 minus 4y. There's step one. I've isolated one of the variables. The second step is now that I have an x expression, I can take my new expression for x and plug it in for x in the second equation. So the new expression goes into the second equation. We've identified x as 6 minus 4y, so I can now plug that into the second equation. So I would now go 2, but instead of x, I can plug in my 6 minus 4y. Minus the 3y that's there equals 1. By substituting in for that x variable, we see we now only have a y variable. So we can, as a third step, solve for the variable that we now have in our new equation. So to do that, straight up algebra, multiply, get rid of brackets, combine like terms, and now isolate your variable. Subtract 12. Negative 11y equals negative 11, and y equals 1. So there's the steps that we can do algebraically. We're not finished. Please make sure, once you've solved for a variable, you now need to solve for the second variable. Well, to solve for the second variable, is if we look at the original, when we're solving for the second variable, we have two original equations, and I now think that y is 1. So I'm going to plug into one of them. You could do it with both to check, but I want to substitute my solution back into one of the original equations to solve for my second variable x. So in that case, I'm just going to do the first equation because it's there. So x plus 4, and we now believe the y is 1, so we substitute that in, equal to 6. And now we solve for x, and we hope and believe that x is 2. So our solution for this system is 2, 1. That's what we believe x and y equal. You can always verify, absolutely to check. I'll leave that up to you for the sake of time in this video. But there's the substitution process. Page 5, there's a second substitution. Y equals x squared plus 3x minus 4, x plus y equals 1. Big difference here is the fact that we have a quadratic now along with a linear. So this is a quadratic linear system. First one was linear, linear. Same process. It's going to be a little bit more work though. So the first thing we need to do is isolate a variable in one of the equations. Well, again, we have choices. But please, isolating an x squared is not a variable isolated. X squared is to have an x squared by itself. You would need to square root to get just an x. So please don't isolate squared terms. We could isolate then, in this case, we could isolate, well, look at that. The y is already isolated. We could also, if we want to do a bunch of work, and isolate the x, or we could isolate one of those, x and y. But like I said, that y is already isolated right off the bat, so we don't have to do anything. But what we do have to do now is take that expression we've created for y and now substitute it into y in the other equation. So we're going to be left with x plus x squared plus 3x minus 4. There now is that y expression that we've substituted in, and it equals 1. So I've substituted in. Solving this time. Big difference as soon as you have a quadratic is you have to solve a quadratic. And that's an earlier chapter in this course, and there's a reason we do it earlier. Solving quadratics, two possibilities. We can factor, or we can always use, if we want, the quad formula. Two possibilities for solving quadratics. Depends on the situation. Remember, the other thing with solving a quadratic, we always need it to equal 0. We need everything on one side to solve. So the first thing I'm going to do is just create my quadratic. My 1 has to come over, so I'm subtracting 1. I have x squared. My x and 3x becomes a 4x. Negative 4 and a negative 1 is a negative 5. That equals 0. Well, at this point, I'm really hoping you're looking at that saying, oh, factoring's a breeze here. Because in order to factor, multiply to negative 5, add to 4. Combination would be positive 5, negative 1. Multiplies to negative 5, adds to positive 4. So we get x plus 5. X minus 1 equals 0, which means our x values, in order to get a 0 here, which is what we would want, x would be negative 5. And in order to get a 0 here, x would be 1. So there's my values for x. But what we have to be careful of is, we subbed in, we solved, is now this solving for the second variable. There's two x's, I need to do it twice. Now, substitute back into, like we talked about, one of the originals. Well, if you're not choosing this to substitute into and you want to substitute into that, you're a geekier math person than I am. Let's keep it simple. We believe that x plus y equals 1. So our first choice was we thought that x was negative 5. So in this case, when I solve for y, I get 6. So we believe one solution is negative 5, 6. But we also had the second solution where we believed x was 1. So 1 plus y equals 1, and in that case, y would equal 0. So the second possibility is where x is 1, our y was 0. So negative 5, 6, 1, 0, two possible solutions. Sorry, this should be round bracket. Two possible solutions for that system of equations through the substitution process. Page 7. Substitution one more time, and we have a quadratic now. A quad and a quad. Things aren't going to change. Isolate one of the variables. Substitute the new expression into the second equation. Solve for the variable, solve for the second variable. So in this case, which variable do you want to isolate? Well, we have x, negative y, negative y. They're all by themselves. Honestly, I don't know if there's a trick as to which one is better to isolate. All kinds of different ways to approach it. What I'm going to do is I am going to isolate this x. That way, I'm going to suggest you stop the video just so you can follow along to the steps that I'm using. Not that I'm right, it's just an option. Maybe that's where you want to start. So, stop the video, try solving, see what you come up with, and then we can do it together. All right, so I need to isolate this x. It's a negative x, I'm going to move it over, bring my negative 1 over, and I'm left with x then equal to 6x squared, negative y, and my negative 1 when it goes to the other side of the positive x is a positive 1. So what I can now do, take that expression and plug it in for x in the second equation. Now quadratic being plugged into a quadratic, this starts to get a little bit big and a little bit ugly. It is what it is. So here we go. 4 bracket 6x squared minus y plus 1 squared minus 4x minus y equals -6. So now we need to do FOIL to get the brackets eliminated. So all of a sudden you start to realize just how big this question becomes. So do you see another possibility to try to eliminate this big ugliness? Now, I apologize for those of you that tried it on your own. Should work out to be the right answer, but one of those moments that's kind of like a teaching moment, and I apologize for doing it to you, but it's kind of fun. Because our x squareds are squared, well, if I plug in for x, I'm going to have to do this great big squaring step. So the trick is, with a quadratic especially, a lot of times isolating a variable, you can isolate any of them. But a lot of people will suggest at times to try to isolate the y. Because when you substitute a y in, you're not having to square it. So let's take a look at this question, but let's isolate the y. So our y is going to go over to become positive. We'll be left with 6x squared. We'll be left with -x, and we'll be left with +1. And so now this 6x squared minus x plus 1 gets plugged in for this y, and I'm just putting in the y. So quadratic. Again, I apologize for setting you up for possibility, but to mess with you a bit, isolate a y, especially when it's a quadratic. Because when I substitute in there 4x squared minus 4x minus, now I can put in the y expression. 6x squared minus x plus 1 equals -6. Now I just have to distribute the negative. I don't have to do a whole bunch of squaring. So you want to be careful. Watch what it is that you're isolating, because as much as any variable could be isolated, sometimes the y is better than the x. At this point, I'm going to combine my like terms. -2x squared, -4x and an x is a -3x. And when I bring my -6 over, it's a +6, so it'll be +5 equals 0. So I now have -2x squared minus 3x plus 5 equals 0. Well, at this point, quadratic, how do I solve? Well, the quad formula, or we could factor. I like the factoring because that's a skill that we use a lot of, so I'm going to very quickly. Can I multiply to get -10, because this is decomp, but add to get -3? So multiply to -10, add to -3. What about -5, 2? So decomp, if you recall, going to break the -3x into a -5x and a +2x. Those two terms now group and GCF. Here I can factor out a -x, which would leave me with a 2x minus 5. Here I could factor out just a 1, leave me with 2x plus 5. So our factored form would be -x plus 1 times 2x minus 5 equal to 0. And so now if this equaled 0, that would mean that x was, if that equaled 0, -x plus 1 equals 0, well then x equals 1. And if this equaled 0, 2x minus 5, add 5, divide by 2, 1 and +5/2 would be the two x values. So quadratic gets big. Got to think. And now that I have the 1 and the positive 5 halves, oh, my bad, I apologize. I made an error. That should be a positive 5, not a negative, which makes that a negative 5 halves. Sorry, my 2x plus 5 and 2x plus 5. It's not 2x minus 5. Whew, big and ugly, lots of room for errors. So now I have to substitute one of those in. 4x squared minus 4x minus y equals negative 6. Plug in a 1. And solve for y. When you do solve for that y, you end up with a 6. So one possibility, x was 1, y is 6. 1, 6 is one solution. The other possibility, we think that x is negative 5 halves. So that one will require a little bit more work. You're going to have to show some steps. I'm not going to walk through the entire process. You should be able to substitute that negative 5 halves in to that equation and solve for y. And in that case, when you solve for y, y equals 41. So the second possible solution is negative 5 halves for x, 41 for y. And there's your two answers using substitution. So again, quad, isolate the y or isolate whatever variable doesn't have a squared in it. It'll eliminate on the amount of work you have to do. Again, I apologize for putting you through that. But here we go. Elimination process now. Second algebraic process. I like elimination a little bit more myself, but everyone has their preferences. First thing you want to do is you want to rearrange both equations so the like terms are aligned. Now this example 3 on page 6, we have our x's lined up, we have our y's lined up, and we have our constants. That's not a big deal. What that's talking about, let's just say you had something that looked like this, and I'm not sure if this would work or not as a question, but let's just say you had a system of equations that looked like that. Well, what's nice is you want everything lined up. Our x's are lined up, but our y's are in different places, our constants are. The suggestion is to always line things up. If I want my x here, I would have to bring my 2y over to make it a negative 2y. I would have to take that negative 3 over to make it a positive 3, and then I would have everything lined up. That's what that first step is talking about. It doesn't really get affected in this first question, but it's important. Second thing, this is where the math has to happen first. This is where the thinking occurs, is you have to multiply one of the equations by a factor so that you have variable terms that are additive inverses. I want my x's or my y's to be additive inverses. Well, in this case, we already have the y's as additive inverses. 2y, negative 2y, they are additive inverses, so I don't have to multiply by anything in this case. Now, I combine by adding the two equations, because 3x plus 5x is 8x. 2y plus negative 2y, well, they're additive inverses, so they give us a value of 0, and that's what's key. If you do step 2 correct and get the additive inverses, one of the variables will cancel out. 19 plus 5 is 24. So there you go. Once you're there, you can solve for the variable that remains, and don't forget to solve for that second variable. Divide by 8, and x equals 3. Well, now that I think x is 3, just like we did with elimination, is I need to plug 3 into one of the equations. And I'll plug it into the first one. 3 times x, which we now think is 3, plus 2y equals 19. 9 plus 2y equals 19. Well, solve for y. And y, 19 minus 9 is 10. 10 divided by 2 is 5. So our solution x is 3 and y is 5. So there you go. That's your elimination. It's all about getting rid of one of your variable terms. So now we have a quadratic linear system. So the quad linear system, same idea. We need to eliminate. First of all, though, do I have both equations so that everything's aligned? Well, my y's are aligned, but now I have x squared x constant. I don't have that. So I'm going to, my y equals 12x minus 1. I'm actually just going to get rid of that, and I'm just going to rewrite it. Y equals 12x minus 1. And if I want, I could even put a 0x squared in there if I wanted something to work with, but I want everything lined up. Now at this point, where we have to multiply one of the equations by a factor so we have additive inverses. Now, again, the x squared isn't what we want to cancel. We need to cancel, in this case, in order to solve, again, it is going to be important with quad systems to cancel the y's. Probably canceling the y, because what's going to happen if I have a squared x, I need x to work with. So I am going to cancel out the y's. So I'm going to multiply this entire first question by -1. Because multiplying every part by -1 will give me -y, and now I have my additive inverses. I'll have a -3x squared, -6x plus 10. So multiply everything by -1, y's cancel. I'm left with -3x squared plus 6x plus 9. And there's now the quadratic that can be solved. Again, I see a GCF of 3, so I'm going to do the factoring process. I want a positive x squared, so I'm going to factor out a -3, because that will leave me with a positive x squared that I might be able to work with after. X squared minus 2x minus 3. What multiplies to -3 but adds to -2? Well, that will be a -3 and a +1. X minus 3 times x plus 1, which means, what are the x values? Well, if that's 0, that's because x is 3. And if this was 0, that's because x was -1. So our possibilities are 3 or -1 for x. So at that point, now I have to solve for y's, plug back into, well, here's one of the initial equations we had. That's what we can plug back into. Y equals 12 times, we think x is 3. So we get 36 minus 1. Y is 35 when x was 3. So 335 is one solution. We also thought x was -1. So y equals 12 times -1, because we think x is -1. Y would be -13. So x was -1, y was -13. There's our two solutions by canceling the y. Again, we want to cancel the variable that doesn't have a squared. Last one, page 7. Well, we solved this one once. Let's solve it again with elimination. So what's nice? First thing, everything is in order. X squared, x's, y's, constants. That's a good thing. Do I have additive inverses? I don't have additive inverses, but I do have a -y and a -y. And like I just said, because I have x squareds, I need the x's to work with. So I'm going to, again, multiply by a -1. That's going to leave me with -6x squared plus x plus y equal to 1. Now there's my new system. When I add those, I'm left with -2x squared, -3x. My y's have canceled, additive inverses, equal to -5. -2x squared minus 3x plus 5 equals 0. there's a quadratic we can work with. Now, we did factor this the first time. We did the factoring process when we got to this point with substitution. So elimination, just to mix it up, I'm going to solve using the quad formula. Remember the quad formula, if you recall, quad formula, x is negative b plus or minus square root b squared minus 4ac over 2a. That's what we need to work with the quad formula. So x is equal to negative b, but a negative 3 is 3 plus or minus b squared, which would be negative 3 squared, minus 4 times the a times the c, and all of that is over 2a, and a is, of course, negative 2, so that would be 2 times negative 2. So 2 different ways to solve the same thing. Now, substitution process, elimination process, 2 ways to get to this, and then 2 ways that we could solve it. So at this point, now we need to figure out what x is, which leaves me with 3 plus or minus this, all this under the brackets, or under the radical sign, sorry, becomes 49. So in that case, what do we have? We have x is 3 plus 7 divided by negative 4, which would be 10 over negative 4, which simplifies to negative 5 halves. The other possibility is x3 minus 7 over negative 4. Negative 4 over negative 4 is a 1. And then finish off, solve for y. Substitute those x's into one of the equations. 4 times negative 5 halves squared minus 4 times negative 5 halves minus y equals negative 6, because I plugged the negative 5 halves in. I'll let you solve for y's for simplicity's sake, save time, but either way, we get the same answers we did last time. Negative 5 halves, 41 is an answer, and 1/6 is a second answer. So quadratic, we can still eliminate, same as we did in grade 10. There, ladies and gentlemen, is your assignment. Textbook, lots of practice, not new. Nothing here is new. We've solved quadratics and linears. We've done elimination substitution. You've graphically solved. It's just practicing now when you have quadratics. Give it a try. Have fun.